types of relation. We have already seen the relation from A to B, but they are different types. First, we'll see many one. Many one. What does it mean? Many means more than one. Many elements. When it will be many one, right? A relation F from a set A to a set B is many one if more than one element of A are related to one element of B. More than one element of A are related to a single element of B through F. That is, for X, Y belongs to A and Z belongs to B, if X is related to Z and Y is also related to Z. Two elements. X and Y are two elements in A which are related to a single element, that is Z. X is related to Z, Y is also related to Z. Not only two, you may relate more than one element, means it may be 2, it may be 3, 4, 5, 6, but they are all related to a single element of B. Let us see. Or suppose we will give an example. Suppose A is equal to A, B, C, D, E. B is equal to P, Q, R, S. Sorry. Right. I will form a relation F1. A, Q, B, R, C, Q, D, S. Here you see, it is a relation from A to B. Why? Because the set F1, it is a subset of A Cartesian product B. It is a relation from A to B. But you see, there are two elements, A and C in A and C in A, C, which are related to a single element Q in B. We can also represent this in the arrow diagram like this. A, B, C, D, E, P, Q, R, S. Right? This is the relation F. You see, A is related to Q. A is related to Q. And B is related to R. B is related to R. C is related to Q. Again, it is related to Q. And D is related to S. Right? Two elements. It is clear from the ray diagram. A, C are related to a single element of B. That means many elements of A, it is A, it is A, it is B. Many elements of A are related to a single element of B. Right? So it is a many-one relation. Then one-many relation. One-many relation. Yes, if one element of A is related to more than one element of B. That is, more than one means it is many. Then the relation from A to B is called one-many. It's one-many. Suppose, and let us take an example. Or in mathematically, in set builder form, in formula order pair, we can write like this. Here x, y belongs to F and x, z belongs to F and y is not equal to z. They are two distinct elements. Y and z are two distinct elements of B, but a single element, that is x. A single element of A is related to more than one element of B, that is y and z. Let us give another example. Say F2. Set is same. A, B, C, D, E. A, B, C, D, E. B is equal to P, Q, R, S. F2. We will take another relation from A to B. Suppose is one-many. AP, AR, DS, CS, CQ, and AS, AP, AR, AS. Okay, this much. Here A is related to P, A is related to R, so it is one-many. If you will find one such example where A is related to more than one element of B, then it will be one-many. Next, we can write it in diagram. F2 at F1. A, B, C, D, E, P, Q, R, S. Say AP, A is related to P, A is related to R, D is related to S, C is related to Q. Right? So, you see here A is related to, it is clear from the diagram. A is related to two distinct elements P and R of P. That is why it is one-many. It is very easy to see whether it is many-one or one-many. It is very clear. If many elements means more than one element of A are related to a single element of B, it is many one. If one element of A is related to more than one element of B, that means many elements of B, it is one many. Then there is another relation which is one relation. One relation. One relation. One relation. From the definition, from this name, it is clear. One is related to one only. Not, it is neither many one nor the relation which is neither many one nor one many. That is one relation. We may say that means if x, y, suppose let f be a relation from A to B, or if x, y belongs to F and z, y belongs to F, but x is not equal to x implies x is equal to z and PQ belongs to F and PR belongs to F implies Q is equal to R. Just see. XY belongs to F and ZY belongs to F. That means more than one element of A are related to single element of Y. Then it will be many one, but it is not many one. It is not a many one means they are not distinct elements. X and Z, they are not two different. Once they will be two different elements, then it is many one relation we have already seen. But this case will never arise. Means if X is related to Y and Z is related to Y, then X must be equal to Z. X and Z, they are not two different elements. They are the same elements. So, yes, and similarly, if PQ is related to F, P is related to Q and P is also related to R. That means one element, that is P, is related to more than one element of B. So it will be one many. If this case happens, that means it will be one many. But we have told that it should not be one many. It should not be one many means these two distinct elements, Q and R, they are not distinct. They are identical. They are equal. Q is equal to R. Then it is called many one. One. It is one. Let us take another example. Say F3. AP, BS, ER. You see, one is related to one only. One is related to one. A is not related to any other element. Similarly, there is, except A, there is no other element is related to P. B, except B, no other element is related to S. Similarly, B is also not related to any other element. Like this. And it will be clear from the ray diagram. Say, suppose it is F3. We have taken it is F3. A, B, C, D, E. P, QRS, AP, BS, right? C, nice, ER, ER. One is related to one only. This is one relation. I have already told you, mathematical relation and social relation, they are not two different. They are not distinct. Same. This is drawn. This concept is drawn from the social relationship. So let us take a social relationship and test which relations are many one, which of them are one many, which of them are one. Let us take. Okay. I'll take two sets. Yes. Let A is equal to Dasarath. Then Ramachandra. Then Janak, Sita, right? Arjun, Humayun, this. Let us take another set P. Ramachandra, Lakshman, Akbar, Abhimanyu, Lava, Kusha, Bharat. Let my F is, I will define a social relation in mathematical way. X, Y, such that belongs to A Cartesian product B, such that X is the father of Y. X is the father of Y. Here you see it will be, yes, is anybody there to be related with Dasharatha? That means when X will be related to Y, if X is the father of Y, X is Dasharatha, then we will go to set B. Who is Dasharatha is the father of, you see, Ramachandra. So the other pair will be Dasarath, Ramachandra. Right? Then Dasarath is also Dasarath, Lakshman. Dasarath is also related to Bharat. Then we will go to Ramachandra. Ramachandra, yes, Ramachandra is the father of Lava. And also he is the father of Kusa. Ramachandra, Kusa. Ramachandra, Lava. Right? Then Ramachandra is the father of any other? No. Then Janak. Though Janak is there, Janak is not related to anybody here. No, because Janak is not the father of anybody, any element inside B. Though he may be father, he may be the father of Sita. Sita is in that set. So here Janak is nowhere related to any element of B, right? Then Sita cannot be the father of any, though Lava and Kusa are there. He is the mother of Lava and Kusa. She is the mother of Lava and Kusa. She is not the father. So Sita also not related to any other element of B. You take arbitrary sets, arbitrary relations and taste whether they are many one many or one. Ramachandra, Lava. Then Janak, Sita, no. Arjun. Arjun is related to, yes, Ramachandra, Lakshman, Akbar, Abhimanyu. He is the father of Abhimanyu, you know. Then he is not the father of any other. Then Humayun. Yes. From history we know that Humayun is the father of Akbar. Right? So this is our relationship. So here you see, here Dasarath is related to three other elements of B. That is, Dasarath is related to Ramachandra, he is also related to Lakshman, he is also related to Bharat. It is obvious, the fatherhood relation, XY such that X is the father of Y. It must be one many, because one father more than one children. Here, Dasarath is the father of Ram, Lakshman and Bharat. Similarly, Ramachandra, he is also the father of Lava and Kusa. Then, yes. So we have got one example where one element of A is related to more than one element of B. So it is an example of one many relation. It is an example of one many relation. Similarly, you can take another example from these two sets. Say, what I can take? XY such that X is the XY belongs to A Cartesian product must such that X is the mother of Y. X is the mother of Y. Only possibility is Sita. Sita is the mother of Lava and Kusa. So this will be Sita, Kusa, Sita, Lava. This is also an example of one many relation. Then one relation. From this we cannot get one relation. Say No. Okay. If this is fatherhood, fatherhood is the, or motherhood is the one many relation. Similarly, with the same set, if we will define like this, what? From set B to A, let H is equal to XY belongs to A Cartesian product B, B Cartesian product A, such that X is the son of Y. X is the son of Y. So it will be same. Son means Ramachandra, and write shortcut Ram Dasarath. Lakshman Dasarath. Then Bharat Dasarath. Then Lapa Ramachandra, Kusha Ram, then Lakshman Ram Lakshman Gula, Akbar, Humayun, Abhimanyu, Arjun, right? So this is a relation, one many relation. It is from B to A. It is from B to A. Similarly, we can write one relation, taking another example, one relation. You find an example where the social relationship is 1-1. 1 is related to 1 itself. From the discipline of our society, if we take say A be the set of Indians, F is a relation from A to A, so that F is equal to, so that means A to A defined as XY. F is equal to XY, such that X is the husband of Y. Then it should be a 1-1 relation. But now in our society it is not 1-1. It is also many 1. It is also 1 many. But it should be 1-1. This relationship. You find another example. Let us take. So these are all types of relations. Now the question may arise in your mind whether a relation is both many 1 as well as 1 many or not. Yes, a relation can be both many 1 as well as 1 many. If it satisfies the many 1 condition, then it is many 1. If it satisfies the one many condition, then it is also one many. Suppose we can take an example, say is equal to A, B, C, D, E, B is equal to P, Q, R, S, like this. Suppose F will be A P, A Q, C, CR, CR, CS. You see, this is A, B, F, A, B, C, D, P, Q, R, S. Here A, P, A, Q, one many. Then CR, CS, sorry, CR, DR, many one. It is one many, yes, CR, DR, right? Due to this, it is one many. Due to this, it is many one. So a relation may be both many one as well as one many. Doesn't matter. Anyway, now let me know if a relation F is a relation from A to B, then how many types of relations from A to B can be? How many different relations can be made from a set A to a set B? You see, suppose cardinality of A is P, cardinality of B is Q, then cardinality of A Cartesian product B, it will be PQ. It will be PQ. Yes. Now what is a relation? A relation is a subset of A Cartesian product B. So what is the total number of relations? Total numbers, not kinds. Total number of relations from A to B. What is the total number of relations from A to B? How can we know? Now, how we form a relation? A relation is a subset of A Cartesian product B. A relation is a subset of A Cartesian product B. So the number of different subsets that can be formed from A Cartesian product B, the number of relations. Yes, what is the total number of subsets? Now it is the nothing but the cardinality of its power set. Cardinality of the power set of B. It will be 2 to the power PQ. 2 to the power PQ. If cardinality of A is P, if cardinality of B is Q, then the cardinality of the number of relations, then the total number of relations, the cardinality of the power set of A Cartesian product B, it will be 2 to the power PQ. That means, if let's see how large it is. Suppose cardinality of A is simply 3. Cardinality of B is 2. Then number of relations from A to B is 2 to the power 3 into 2. That is 2 to the power 6. 2 to the power 6 means it is 2 to the power 6. 64. Okay. So a huge number of relations can be made from A to B. 64. Simply, if cardinality of A is 3, cardinality of B is 2, then the number of relations from A to B is 64. So students, you try yourself, take examples A and B, try to form different relations starting from null set, starting from the trivial set by empty set, null set, starting from that to up to what? Up to A Cartesian product B. That is the largest relation from A to B. which is called the inversal relation. Inversal relation. So the total number of relations will be 64. Try yourself at your level. Okay, and this finishes your 11th class review classes. Now in my next lecture we will start the relation defined on a set and some special types of relations defined on a set A, which is in your course, in the 12th class course. Okay, bye.